All right, today we'll be diving into the world of Python that includes machine learning. So we'll explore how Python with powerful libraries like scikit-learn, TensorFlow, and PyTorch that enables a computer to learn from data. So what is machine learning, by the way? So ML is a field of artificial intelligence where a system use data to learn and improve the performance of specific tasks without being like explicitly programmed for each cases. So instead of writing it rules, so we feed data to an algorithm and it learns that patterns. So there are different types of ML, but we'll mainly focus on supervised. So what is supervised learning? So this algorithm learns from labeled data. This means our training data includes input features and corresponding correct output labels. So this has two things like a regression classification, like regression nothing but predicting a continuous value, for example, predicting a house price, predicting stock price, temperature. And classifications like whether it is a spam or not, whether it is a cat or dog. So unsupervised learning, so the algorithm learns from unlabeled data, like finding pattern and structures on its own, like a cluster form. And also there's one thing called reinforcement learning. So an AI agent learns to make decision by taking action in environment to maximize a cumulative reward, like training a robot to walk or training a robot to play a game, training a robot to do some kind of task, and it learns from that. So our main tools today is scikit-learn, also called as sklearn. You guys maybe have some familiarize with scikit-learn. So the go-to Python program that is scikit-learn it has machine learning tasks, like it provides simple and efficient tool for data mining and data analysis, like including many algorithms for classification, regression, clustering, dimensionality, model selection, pre-processing, etc. And TensorFlow or PyTorch, like it powerful open source libraries primarily used for deep learning. To use this, you can just install pip installs scikit intention learn scikit TensorFlow PyTorch. So TensorFlow and PyTorch can be large. So for today, we'll stick to scikit learn. So if you haven't not installed scikit, please install it before you move to the program. So the fundamental idea in scikit-learn is supervised machine learning. So is that we have a data consisting of features like input is always denoted as X and label that is output often denoted as Y. So a machine learning model learns a mapping from X to Y. So again iterating. Input often denoted as X and output as Y. And it learns from a mapping of X to Y. Scikit-learn also has a very consistent and easy to use API pattern for its model. Like the import model Take class you want to use. For example, from scikit-learn, you can use linear regression, or like we have said, classification in Coursera. And next thing is instantiate. So it creates an instance of the model. For example, model is equal to model class and parameters. Like you can often adjust the model behavior with parameters. And the other one is train and parenthesis fit. So you train the model on your data. How? X to Y mapping. So this is where the learning happens. And the last one, the predicting. So it's make prediction on new unseen data, like prediction is equal to model dot predict parenthesis test. Like you can see on the screen, read and go through once. Then we'll have the consumption like regression model. So on the screen, this is an example. It is conceptual. Then later, after understanding, we'll try to create a regression with scikit-learn from scratch. So here, the, the the model learns the slope m and intercept c. Like here we have conceptual data like X is the hours of study and Y exam score. So what happened? X training nothing but a line of array. So it's 2D structures. Below it will be 1, 2, 3, and the on y-axis, like in better if you have a geometry of class, then you gotta see. And the y-axis, like on the array is like 50, 60, and goes on. And we import and then initiate like we read in above, and model or feed nothing, it trains, extend the y train, and the prediction happens with the down. That model dot predict. This how it's gonna be like. Now a concept and classification model like predicting a category. Imagine we want to predict if it's an email is spam or not a spam. We have a basic features like number of certain keywords like logistic regression, like this part is name used for classification, or something we can even go with decision tree. So it can learn to distinguish between these categories. So we'll implement both regression and classification. So this is how it's gonna be like. So let's make this more simple and runnable. So this is just a concept. So, guys, go through with me. I want everyone to follow because I make mistakes. I make a lot of mistakes. I want someone to point it out for me. So, first thing we import numpy. This thing. Now, this is where I expect it has a on-to-go library for like now we'll go in linear regression. So we'll import linear regression from scikit-learn. So we selected a model here. So we're just testing it. And now we'll generate some random sample. Let's say I guess this is an example which is already available in it. Can even refer if you want. There's many ways you can write it. So what happens here is this random data has like point, like future or hour studied. So something even called noise. So I'll explain you guys when I'll just type it out so I can know what I'm doing. All right. So starting here. So this is nothing but we generate some synthetic data where y has a roughly linear relationship with x, but with some noise. So we created a seed with 42, and we created a random noise here. Yes. So this function is crucial, like it splits our data set into training set here, and also testing state as well. So which is nothing but it used to evaluate model performance on unseen data. So this helps prevent overfitting. Overfitting nothing but where a model performs well on training data but poorly on new data. So here, as we discussed, this is where the training usually happens. So this attribute stores the parameters that is slope and the intercept learned by the ingression in above. And the prediction happens here. So the model predicts y values for the x test data. All right. So MSE here is a common way like to measure the average square differences between the actual and predicted data. So but for better, let's have plot calls. Maybe you guys have clear example like how it happens. Plot, I guess. Okay, real. So we will think it's what is all right. Guys, go through the code before we run. Go through the codes and ask me if you any doubt in any of the line. If you didn't understood, it's nothing but if you go line by line, we are importing NumPy matplotlib for plotting and scikit-learn for has a linear regression and transmit model. We're just running the random seed data and also increasing noise. And noise is nothing but how do we want the y-axis to be. So this thing you can understand when we plot the codes. And we are splitting X train. X has a testing in white and then Y has a test. That's in the predicted data as a split. So X to Y, the split size is nothing but 0.2 and the random state is nothing what we have mentioned above. Let's just run and you will know. All I told I'll make mistake. Which line is that?
Line number 9.
Come on, guys. Who's in front of you? Tell me what happened here. Anyone? Because I even gave you clue when I said I was explaining prediction line. So anyone not even raise the voice telling me where the prediction happened, where is the data for the prediction, where is the model training in the prediction. So, so far, so no issues. I'll give you guys time. And fast, if I hope you're using VS Code, just type the line, it will just give you the randomized data. These are the examples already available, it's three different examples. Since we don't have time to create our own thing and we need a lot of brain stuff to create our own thing here. You can practice if we have real world example, if anything. Yeah. So machine learning is nothing but set of math. So if you know math, then you know you can learn it easily. So I'll give a couple of minutes, look at the code, understand what happened, and if you guys didn't understood, ask me in the doubts. Is the screen okay if it's like this? Okay, I'll just skip the import path. I'll give you 500 then. Does anyone have any doubt? People, just tell me if you have any doubt, then we can move on. I guess many of you have doubts here. This is nothing but so np.random.seed. So it is a random number generator. Like it always gives some random numbers each time when you run code. So this thing generates random between 0 and 1 has a column, and 10 is nothing but a scale between 0 and 10. So like you're creating 100 random x values between 0 and 10. Alright. There's nothing but this is noise. Noise is nothing but the same thing in 2x speed. Why we are having noise is here to add some realistic thing to your data so that we can tell the model that this data is like for example, if that doesn't mean that if you study for n like 10 hours you might score better. It depends. We're just adding some noise here. I hope you guys don't have any doubts. So scikit-learn is a fantastic for many ML tasks, especially with tabular data like we have shown. However, for complex unstructured data like images and text, deep learning models like TensorFlow and PyTorch comes to the scene now. So why? Because deep something called neural network that is automatically learn these hierarchical features from raw data. For example, let's say from pixel or let's say from a network. So then it will learn from like it can learn from the shapes and the object type and the whole object. If you dive deep, then it would like so it's for just for image conceptual speaking. So for data representation, instead of we created a linear chart, how about in image? So images are all represent as get a pixel, right? So each pixel has a value. For example, maybe like between 0 to 255. So color images have multiple channels from red, green, blue, in like in shorter form RGB. So this forms a 3D and like NPY array. Like we just found 2D way. It's gonna be like 3D that contains height, width, and channels. So a special type of neural network called CNN, called like neural networks. So they use these convolutional layers to detect patterns like edges, textures, and goes on. So training like a large model from scratch using the image is like very require like a lot of computation power and GPU. So fortunately, many pre-trained models are available. So for example, there's one model called VGG MobileNet. So that I've already learned about these powerful features from this thing. So because we can't able to run this conceptual thing, so let's see yeah, theoretical idea for using pre-trained model with, let's say we have a keras, so which is a part of TensorFlow. Actually, running this requires TensorFlow installs and downloading many more other models is a very hectic part to work. All right, so let's just type some conceptual model, how it's going to be like that. I may not know this in detail. Let me try. So let's just say we have something called from TensorFlow. Because I to have here import Keras. Yes. Keras is nothing but application. We can even import other flow. Yeah. And now let's say we import numpy as well. So we have TensorFlow has image processing capabilities also. For TensorFlow, why it's not giving. Yes. So we have to load a pre-trained model. Example, Keras. For example, we can even import some model of this one. Yep. Let's import mobile net for today. Because we won't be running this model because we can't run. This is just conceptual. So let's say we are loading this model here. Model mobile. Right. So how to load your image in here? So we can load image like path. So it's nothing but path of your image. And we'll assign that image to an X variable. So it expects this image to be loaded in IMG. So we can use it shorter. And we can even add dimensions. We can even use scaling. So this is how we can import image in here. Same like for prediction. Same model. So this would show the prediction image. Let's just say I want something, let's say top three predicted in class. Let's say a cat. What are the top three cats? Let's say Egyptian cat. Tiger is also comes in a cat and goes on. So these are the conceptual thing. So we won't be running. So because the key idea is it has to load a powerful pre-trained models. So this is how it can prepare your input image and it should leads the image to match model the model experts and then it gets a prediction out of it. All right. So this it also have text analysis for data representation. That text needs to be converted to numbers for machine learn. Then tokenization, nothing but breaking text into the words or subwords. Then something called vectorization, or in other words, it's also called embeddings. So what happens after tokenization? It converting tokens into numerical factors. For example, it's a simple method. Uh, we have something called bag of word or some file of so tokens. So we can even use word embedding like we have fast text mostly used. So this is a conceptual because this requires a deep thought and from like it's a big thing. So I just want to give you guys the conceptual idea how we can use TensorFlow and train the model. So any doubt guys until here? So if you guys have any guys lost in between or any doubt. I know it might be confusing you, but when you guys learn one by one as a big brief topic, then you'll have some clear cut example, clear cut definition of each and everything. So regardless of whether you're learning Scikit or TensorFlow or PyTorch, the general machine learning workflow is similar too. Yes, Bhavesh, you have any doubt?
आपकी शादी के टाइम पे भी ऐसे ही लफड़े हुए थे।
Bhavesh, your mic is on. Do you have any concern?
ऐसा तो इन लोगों ने बहुत झूठ बोला है, ऐसा तो मार्केट जा रहे हैं, ये कर रहे हैं, वो कर रहे हैं। पहले भी जब आया हूँ मैं सब समझ गया हूँ मैंने सीधे पूछ दिया कि आज मार्केट तो बंद रहते हैं, मैं समझ गया था कोई मार्केट वार्केट। अब ये मेरे को ये नहीं पता कि कहाँ जा सकते हैं, इसका मेरे को ऐसा आइडिया नहीं था कि मन्नू के मन्नू वही कर जा रहा है। ये तो समझ गया था कि झूठ तो गारंटी बोल रही है, तो 100% है। ऐसी बारिश पड़ रही है पहली बात तो, ऐसे में मार्केट जाएंगे और मंगल के दिन बातें वो करो जो सच लगेगी।
I have muted him. So where was I? So all the machine learning workflow is similar. So it follows the same thing. Like problem definition starts like clearly define what you want to predict or what you want to discover. And data collection, like we gather how relevant data. Preparation to pre-processing, like this is often most time-consuming part. Like first we have to clean, like whenever like handling missing values or outliers, etc. And we have to transform, like scaling, encoding, categorize the features, and something called creating new relevant features. Or any we can even split data into like what you want to train, what you want to validate, or what you want to have as a test sets. And model selection, always you have to choose an appropriate model or algorithm based on your requirement. For example, for regression classification or for data type, or is it image or it text and goes on. So to train your models, we have a universal thing. So during training, the model learns the underlying patterns and the relationships in the training data by adjusting these internal parameters. For example, how the weight in neuron or the coefficient in the linear regression or what we did before, and many things. Uh, like what we did before, like we access the model performance or unseen data, like the test set which we use using MSC to mean. So we can even adjust the model settings like called like hyper parameters, like to improve performance. Like many deep things when we have to when it comes to deep learning, machine learning. So pretty we gone through prediction today using that linear regression. All right. So training deep learning models for image and text analysis, we can use that PyTorch, TensorFlow. Like we had a conceptual thing here. It also requires a computational intensive or often require GPUs for speed and can even take hours to take the data out of it. So we had an introduction to exciting field of machine learning. we saw like how scikit provides user-friendly framework using Matplotlib. We conceptualized touch how TensorFlow, PyTorch are used for deep learning, especially complex data like images, text, and the importance of data processing. We also maybe the project might be related and depend on machine learning. So guys, please have a note on this. So the key message is that whether it's machine learning or deep learning, it's always heavily data driven. So your skills in data manipulation with pandas and NP are absolutely foundational here. That's why we have taught you guys this before. So this is a vast and rapidly evolving field. So there are many resources to dive deeper into specific algorithms, architectures of models, and practical applications. So always ask you guys to practice these things stuff. So these are just the beginning. This is like how a flow and framework goes on. These are the examples I could get you guys very understandable because visual learning is not something a cake which you can just eat, but it's a very deep process. So if maybe many of you guys would not understood, many would have been stuck. So go through once again. So when you do the project, it might help you a lot. So any questions?
Sir, do we need to install Anaconda to access all these libraries, or should we use just pip?
Anaconda, it totally depend on you. Like if you're using VS Studio, use that. If you want to use Anaconda, it's up to you totally. You can even use PY Charm as well. But I
Okay,
suggest you to VS Code since it has that AI ability and AI helpful guide, so it will help you code better.
okay. So otherwise, we can use pip, right, to install all this.
You have to use pip to install it.
Okay.
Alright, guys. I assume you guys don't have any doubts. So see you looking forward for the next session. We'll have an even more exciting chapter, and next time we'll dive this into deep. So let me know if you guys have any doubts, else you can do the session and have great rest of the night. Seems like you guys just turning on and just doing your other works. I guess not good, guys. It's something you have to learn and you opted to learn. All right. If any doubt, bring me up.